The section of the text we're in now is on transformations, which is there's a couple of different things here, but for the most part, there's some concepts and go through and work the problems, and he's got them as typical broken out very carefully. But I'm going to kind of cover them in one grouping. A transformation is a one-to-one correspondence between points. So if we have two different figures and two different triangles here, and it doesn't matter how I really hold the triangles, but I can see that there's a one-to-one correspondence. In other words, if I put them on top of each other, clearly that they have correspondence. And if I move them over here in two different places in space, points in every other point in the triangle. Same thing if I take a triangle that's smaller. Now these are symmetric triangles, but they're not equivalent triangles, but still there's a one-to-one correspondence between all the different points in the triangle. So point A up here is correspondent with point B on this triangle, and so on. Now, so that's a transformation, and then there's subsets of transformations or subcategories that he defines. A translation. A translation is when we take something like this and we slide it over. So this is nothing but this figure slid over to this position. So it's a translation or a slide. Then we could have a reflection. Now what we typically think of as a reflection is when we look in a mirror, we see a reflection. And what it appears when you look in the mirror is you're seeing yourself. If you're standing 1 foot in front of the mirror, it appears there's another person that looks just like you, looking back 1 foot behind the mirror. So the mirror is the line that divides. So if we reflect, and we have a line here, and we're going to reflect this triangle around that line, then what it looks like is this. And so there's a line right in the middle, and so like on a piece of paper, if I folded it on that line, it comes back and forms the same thing. And a lot of times we do this when we do a piece of paper or play some of the games where you're cutting out shapes in paper, that you're actually using reflection. Rotation is so a reflection, it tends to be around a line. A rotation tends to be around a point. So if I hold a point still and then I can rotate the figure, but one point is still intact, and so that is a rotation. Now, obviously, if I rotate all the way back around, I end up in the same place that I was in. So these three translations, reflections, and rotations are all transformations. They all move things around in one-for-one correspondence of points. And they're all called isometric. These three are called isometric, meaning all the angles and all the distances, all the lengths and the angles are preserved. The figures, when I cut them out, no matter where they are, no matter if they're rotated or if they are reflected or if they're just translated, that if I cut them out, they will fit on top and they are the exact same figure on top of each other. So that's what isometric means, is they are equivalent if you cut them out and put them on top of each other. As opposed to a dilation, which is where you shrink or expand the figure. So that's what we think of as something is in proportion. So here's a dilation. These still are the same triangle. They're still symmetrical, but when I put them on top of each other, clearly they're not the same size. So this one is shrunk from this one, or this one is expanded from this one, however you want to look at it. So there's a dilation that goes on between them. Obviously, this is not isometric because the angles may be preserved, but the lengths of the sides are not. So these are the couple that you see. Now there's some other things that you'll notice out of here. You can sometimes do multiple. For instance, you could reflect. If I took a line here and reflected this figure, and then took another line and reflected it again, I'll end up with it over here. So I've reflected to here and then reflected this one again into here. So two reflections have made, in fact, a translation. So you can see that some of these concepts are certainly all related to each other. All they really mean is I'm moving a figure from one point to another. now we get back to